Hi everybody and welcome to Olalla Canyon. Ooh la la. Stupid. We've got some outcrop here of the Swakane biotite gneiss on a beautiful, peaceful Wednesday morning. Let's look at some details in the outcrop and then let's use some recent work to really dwell on the fact that this Swakane gneiss is important in a regional story. Thanks for joining us. Hope you enjoy this episode. All right, looking up into the enchantments and the Stewart Range, you're looking southwest. And if I zoom back out for you, we can get a sense of where we are. Olalla Canyon looks like this. Very quiet this morning, not much traffic. There's just a few homes up the valley. And I'll give you a GPS location in the link below, in the description below, so that you can find this place, as I've been doing this spring. But there's actually a nice little mile marker number 4 to also kind of give you a landmark to know that's the spot. So circling back one more time, there's a convenient little pullout right on this corner. Tibbetts Mountain is an old Forest Service road hike up into the clouds. All right, well, from this vantage point, let's just give you a sense of the outcrop here. This is certainly not the only place to study the Swakane gneiss, but this is the spot I've chosen. Okay, so the outcrop, how would you describe it? I don't know if it's that impressive necessarily. It's resistant. The rock looks kind of hard, doesn't it? It's not a bunch of soft swales, but it's kind of a stubborn outcrop form. But if we come in a little closer, still just try to make some observations. And if the light cooperates with us, this is a metamorphic rock, so there are some good-looking foliations of different scales. In other words, kind of banding or stripes. The minerals are not randomly arranged. I'm going to zoom in a little bit more because I can't hop up there. Oh yeah, that's pretty good. I don't know if it works for you, but that's... So like a good metamorphic gneiss, we have kind of white bands and black bands, white bands and black bands. Notice the foliations are kind of folded a little bit. And then if we come down to this scale, we can even get a better look at that. Okay. Yeah, the sun's out now for us. Let me come again, before I start breaking a few things open, let's just try to slow myself down, give you a chance to observe. So while I'm, oh yeah, nice. No pun intended. Maybe it was. So while I'm doing this with you and we're just slowing ourselves down, trying to make some observations, I'm reminded of most of the geology field trips that I was on when I was a student. And there rarely would be context given. There rarely would be any kind of regional significance of a location. It would just simply be, okay, well, you know, what kind of rock is this? And then you kind of pretend you know what you're doing and start banging on a bunch of rocks, but nobody really knows the answer. That's beautiful, isn't it? And then the instructor or the TA or somebody finally kind of says, okay, well, what do you think this is? And then everybody stumbles around, then you finally come up with a rock name. And then you may be told what the name of the formation is, or the group is, or whatever. Then you go jump in the vans and you go someplace else. It's like, what? That's not the fun part. The fun part for me is making connections with distant places, if that is a possibility. So let's Sure. Let's try this. Hi-ya! Hi-ya! Okay, zoom for you. Hold it still, boy. We need a weathered surface. You can kind of see the foliations, but we can do better than that. Sun just went behind a cloud. Maybe that's going to help us. So this is a foliated metamorphic rock, rich in biotite mica. There's looking down on the black mica flakes, biotite mica in other words. In cross section you can maybe see, I'm out of hands, but the biotite is platy. The biotite is not randomly distributed, but they're all parallel to each other. And one of the remarkable things about this Swakane gneiss is that over 90% of the bedrock in large areas has this look, has this exact look. There's hardly any variation. So I'll take a few of these blocks that have fallen down off the cliff, get out of my own shadow, and maybe try to give you more of a sense of this biotite gneiss. We're going to talk about this a lot this winter. This is a key bedrock unit for the Baja BC discussion. So my mind is already to November and December, I gotta say. I don't know, do I need to break anything else open? Let me try one more. Let's go over here. Sure, let's try this. Yeah. Oh, it's a good fresh piece. Oh, I should have stretched out. I mean, you can almost see the foliations better when it's weathered. I don't know, I'm just trying to look through my camera lens here, but I hope you can see the well-organized behavior of these platy biotites and therefore the quartzes that are in between. Now this one's kind of cute. Yeah. Get out of my own shadow. Yeah, I like this one. Whoa. Big old quartz vein in amongst this. Beautiful quartz vein. Oh, sparks are flying. All right, well, maybe you get a sense of it now. Okay, so let's head over to the maps and make some connections. Why is this such an important unit on such a quiet canyon road? And you know, much of the scenery you're seeing is built of this gneiss. Okay, well, let's sit in the chair, get the sun over my shoulder, and we'll look at a few maps. Why not? Okay, here's the Stewart Range, Mount Stewart, Pluton. Here's Wenatchee. Here's the town of Chelan. Here's Lake Chelan, heading up into the North Cascades country. This color, with this old map from 60 years ago, all this kind of pale green is the Chumstick Formation. Big old sandbox, Aaron Donaghy country. Arcosic sandstone, conglomerates, shales, we good. But today we are in this thing, this little island of darker green. So if you can look carefully, I don't know if that's possible, if you drive upriver, up the Wenatchee River from Wenatchee, you get to Kashmir, which is here. You eventually get to Leavenworth, Washington, which is here. But I'm in Olalla Canyon, which is, I don't know which one, I guess it's this. Yeah, it's this one. So I got onto this road. So Peshestin Pinnacles with Randy Lewis is just right around the corner here. But I've driven up Olalla Canyon, and I'm right in the middle of this dark green island. So I'm surrounded by Chumstick sandstone, essentially. But this is Swakane biotite gneiss, and all this is Swakane biotite gneiss. So let's go to a different map from Ralph Hagerud, 2009. Different color scheme. Sorry, gonna have to deal with it. What we have here is Wenatchee. Here's Swakane biotite gneiss in this kind of snow white. And now here's our snow white island of Swakane. Here's Olalla Canyon. We're right here. KSWG, in other words, is Cretaceous Age Swakane gneiss. And then on this map, Ralph Hagerud's 2009 map, this is all Chumstick Formation, Eocene in age. Now, it might be interesting to you to know that this Iniat Fault is a major strike slip fault with at least 30 kilometers of offset, maybe more. So this Swakane gneiss, where we are, is the same as this Swakane gneiss across the Iniat Fault. But since there's been 30 kilometers minimum of offset, this stuff should be way down here underneath Wenatchee, or possibly even way over here, was originally, in southeastern Washington. And every earthquake, when the Iniat Fault was active, got this Swakane gneiss up next door to this stuff. And that means, yes, there's some Swakane gneiss that used to be a continuation of this stuff that's been shifted further northwest into the North Cascades. So is that the regional story I'm talking about? Is that what's so significant? No. Hang with me. Hang with me. Even on this cover of the second edition of Roadside Geology of Washington, you can see our little island of Swakane gneiss. Now we got colors again that are different. You see how this works? We got colors. Every map has a different color scheme. Now here's the German chocolate cake, southeastern Washington. And this dark purple is Swakane, and the dark purple there is Swakane. Okay. More maps, different color scheme yet, and then we'll finally land on what I want to do. A little sneak peek to Baja BC. Page 127. Marley has a map for us. And now the Swakane biotite gneiss, can you see what color it is now? It's orange. KSG. And yes, we are here. And yes, there's Swakane gneiss on the other side. On a roll. If you're more familiar with the Wenatchee area and not this little canyon, Turtle Rock sitting in the middle of the Columbia is made out of the Swakane gneiss. There's good exposure of the Swakane gneiss on the east side of the Columbia, like if you drop down from Waterville, make that dramatic descent, there's plenty of Swakane gneiss in there. And then, yes, you can see that there's plenty of bedrock between Iniat and Wenatchee that Swakane biotite gneiss. Okay, well, let's finally get to the point of this with Baja BC. I'll just show you my notes and I'll narrate. How about that? So I sat down for, I don't know, half an hour before I left the house this morning. And I sat down with a paper by Kirsten Sauer and her former advisor at University of Nevada, Reno, Stacia Gordon, Bob Miller, San Jose State, in other words, Stacia and Bob from the Dream Team. And a paper came out in 2019 making a case that the Swakane biotite gneiss and the details of the detrital zircons pulled out of this Swakane gneiss, which is interpreted as a metasedimentary rock that has a deep crustal origin. In other words, this stuff became metamorphic when it was 40 kilometers depth in the crust, is remarkably similar to some schists and gneisses in the Mojave Desert of Southern California. The Pelona schist, the Orocopia schist, the Rand schist, the Sierra de Salinas schist. And you're like, 50 years ago, you go, this stuff looks pretty similar to each other. Interesting. But the techniques that we now have help us realize that it's more than just a vague similarity down to the zircon level. And other outcrop observations, there's a remarkably similar match between the Swakane gneiss here in central Washington and these schists that are east of Los Angeles. Both are homogeneous, feldspathic schists and gneisses. Strangely, both don't have any plutons invading, and that's especially noteworthy up here in the North Cascades because we have so much pluton invasion, but there's nary a pluton invading this Swakane gneiss. The base of the Swakane gneiss not exposed here. The base of those schists in Southern California not exposed. And there's a low-angle detachment fault separating both of these in Southern California and Central Washington with the overlying older material. If you like the Swakane and the POR schists being next door to each other, in other words, continuous in Southern California once upon a time, that means that the Swakane used to be in Southern California. This stuff here is Southern California bedrock that's now up here near Wenatchee, Washington, and to do that we need 1,000 miles of northward migration, aka margin parallel translation. Essentially, this is matching bedrock. So why did somebody even have that idea? Well, I think you know the answer to that. This is the 50th anniversary of Baja BC, the idea first put in print, and the Paleomag suggested that rocks in central Washington used to be in Baja, Mexico, proposing 2,000 miles of northern migration as opposed to 1,000 miles. But the point is, if you look at the Swakane gneiss and try to match it with something further south, the study in 2019 by Kirsten Sauer and others suggests there's a good match with the metamorphic rocks in the Mojave. So you could call it Mojave BC as opposed to Baja BC. And yes, if we don't take the route of matching bedrock, and we don't take the route of looking at the paleomagnetic studies, we could also just simply look at the known strike-slip faults that we do have in the Pacific Northwest, restore all those known faults, and that gets us to have this material 500 miles south of where we are at the present-day latitude of Oregon and California, the Oregon-California state line. So depending on which data set you look at, this bedrock was not created here, for sure. At minimum, this Swakane gneiss was created in southern Oregon. At maximum, it was created Cabo San Lucas, Mexico. And a moderate amount of translation, the study we're talking about today, puts it at the latitude of Los Angeles, California. Much more to come, but here's a taste of the Swakane biotite gneiss. Thank you. I love you, and goodbye.